Hi, Kate. Can you hear me?
Good afternoon.
Oh, hi. Yep. I can see you, so it's good. I'm not sure. Let's see. Do you see anything of me or
I do not. I see your screen.
let's see. I'm not sure what you see. There's a camera, but I don't see a feedback on
On your screen, I just see your desktop. So I see, it
Do you
looks
see
like you're,
it? Yeah. Oh, video. Wait, I see. Video. It should be showing a video of me from the Stellatron. See, I haven't actually used this. Anyway, we can hear you, so that's good.
that is good. That is the first.
Let's see. So, and you can hear us, but can you, someone in the audience say something like, so you can tell if she's going to be able to hear? Somebody say hi. Did you hear ice cream?
I did not know.
Okay, that's a problem. All right, so I got kind of,
I also just tried to share my screen or share my window, I guess I should say.
yeah, I can see it.
Great. Do you see the right version of it now? Is it presentation mode or presenter's view?
That looks good. That looks really good. All right, so, let's see how this goes. I want to be able to interrupt you while you're talking so they can ask questions and things. So if it looks like that's not happening, I'll just jump up and come up here. I know you can hear from here, so, but there is a mic, but I don't think it doesn't seem to work. In fact, I've had no problem with getting this. Anyway, I think it's just a mic.
I hear a lot of voices. That's probably just the natural chit chat of the classroom, I'm guessing.
Yeah, so that's what, I mean, I think, if not, it's all right.
Austin?
Software. Have mic on table.
I think definitely, maybe the last time. Just have to ship up Mrs. Jones.
Oh, are you signing in too?
No. For is it better to make a cam for her?
Oh,
The cam for the students.
Ah,
Like
oh,
this, yes.
okay, yeah,
Is it better?
yeah, that's good. It
Okay.
would be good if it. Oh, that looks really good. Oh, you mean you're using your camera? All right,
Yeah,
that's
yeah.
great. All right. You put the computer here, and it shows how it's
Like little shorter thing, like this one doesn't fit.
Yeah. Right. So,
And it fell off. Wait, can't really come back.
Right, so let me get started. So, yeah, let me get started. So Kate Pierce is here. Yes. Quiet down. Okay, so she's here. She's the director of National Institute of Standards Material Measurement Lab, and then had her. She created the circular economy program like this. So NIST, she'll explain a little bit more about this. As part of that, she does that. She's also been like a lot of things. I sent this out. I think you guys read it. So pretty extensive and impressive file. Hopefully we can get some discussion going about recycling plastics and circular economy for plastics and how NIST puts into that, and basically your opinions on this. Be good to hear. So is that okay, Kate? I've already sent out.
Yep.
It's an impressive bio. I mean, so this is the first right now. And you can see the class, kind of some part of it in the middle of the name. Hopefully we can interrupt, like get discussion going. That's the whole. Otherwise, so why don't we get started?
Sure. Yeah, you all can hear me okay? A fair amount of echo. Do I? No,
Yeah.
it's good. It's okay.
No, it is.
Okay.
So,
You just need to mute.
yeah, I need to mute, but let's see if I can figure out. Is that the mute button? Yeah, I think it should be muted now. It should be okay.
Okay. Is that better?
Yes. I think.
All right, good. All right. Thank you. I'm happy to be here to talk to you. Yeah, like Professor Beaucage said, I have a background of doing a lot of primarily research until about 5 or 6 years ago. And in recent years, I've been building a circular economy program at NIST for plastics and then working a lot with other agencies. So I figured I should probably start by telling you what NIST is, because most people usually don't know. Unfortunately, change that. So the National Institute of Standards and Technology is a government laboratory. It's a federally operated laboratory, which is a pretty important distinction when it comes to thinking about national laboratories. We're part of the Department of Commerce, which again is also not a place people think about having national laboratories. Usually they think of the Department of Energy or NASA, occasionally the Department of Agriculture or NIH, but NIST is part of Commerce, and it's our mission. Part of our mission was stated in the US Constitution to maintain a system of weights and measures. If you're not familiar with our system of weights and measures, I strongly recommend you Google Saturday Night Live's George Washington skit on weights and measures, because it is both hilarious and also speaks volumes about our system. So that office has been in existence for something like 200 years. It is operated through NIST. And since then, our mission has expanded dramatically. We are basically the keepers of the US measurement system, and we support global exchange of measures, which are very important to support commerce and trade and to enable innovation to work seamlessly in the economy. At its base, it is traceable to the 7 fundamental units, the SI fundamental units, the kilogram, the meter, the second, the amp, the Kelvin, the candela, and the mole. But there's many things in the real economy of manufacturing and trade that actually can't really be traced to those things. And so the spectrum of things we do at NIST is enormous, from building the world's best atomic clocks that support satellites and market trade and Olympic timing and all those things, to providing a reference material for farmers to be able to track PFAS in spinach or in cow's milk to support agricultural safety measures in the food supply. It's an extraordinary range and a really interesting set of things that we provide. The lab that I run is primarily responsible for chemicals, materials, and biology. So that's everything from antibody reference materials to steel Sharpie tests. So my husband works for the nuclear Navy, and he got really excited to know that I was going to be responsible for the Sharpie. I think it's ridiculous, but also it's amazing. It's a very important thing, but yeah, so where does polymers fit into all of that, and where does the circular economy fit? So when I was given the opportunity to build a program, I was really interested in this kind of duality of polymers. And some of this, I hope you already know, but I wanted to touch on a few key points to sort of set the context for my role as a public servant working for the US government in this space. So it's really important to remind everybody that polymers are probably one of the greatest waste stream solutions of the 20th century. So we used to just bleed ethane and propane off of our fuel supply in doing refining of gasoline because it was too volatile to transport. And some folks won a Nobel Prize in the 50s for being able to fix it into polyethylene and polypropylene. And it has benefited from, depending on how you count, anything from 50 to 100 years of really intense investment in the manufacture of these things, right? We have spent a tremendous amount of money and gotten extremely smart about extremely complex front-end supply chains to produce a really broad range of materials and products. It's extremely valuable. It's in absolutely everything. And it's a really important resource. The problem is that we don't always manage it that well. And for all that attention we spent on the front end, we've really almost completely ignored the back end. And maybe arguably been a little bit sloppy about our sincerity and our efforts to address how we manage recovery of these materials and where they end up. And so two things happened in the 2010s that were really important. Two geopolitical events sort of converged. One was a massive disruption in the trade of a fairly junky, unreliable recycling plastics industry that we had sort of propped up. We had been shipping huge amounts of poorly sorted plastic to countries that decided they were no longer going to take it. And you can argue about why that was or whether that was a good idea, but the reality is that's what they did. And it was a massive economic disruption to the system. And at the same time, there was a growing focus of attention from the environmental sciences on the impacts of plastic when it leaks. And the awareness of those kinds of issues and people asking questions, whether or not we were, I have a couple slides if you want to talk about it, whether or not we were very precisely or accurately measuring the problem, really, people were having a growing interest in understanding it. And it is clear that a lot of this material was leaking to the detriment of. So you've got these two, all of a sudden these two communities are both interested in the same thing, the supply chain and the economy and manufacturing wants to get that system back up and operating again. And, you know, the writing on the wall is that there might be some policy affecting their ability to operate through this business as usual model. So I think it's really important to talk about definitions because we support standards. We think about definitions a lot. And finding the circular economy is not easy. You will find, I think there's a tongue-in-cheek review that says there's something like 180 definitions of the circular economy in the scientific literature. The government tends to pull from the Ellen MacArthur Foundation, which is EMF on this slide, or a bill that was passed about 5 years ago called Save Our Seas 2.0, which is really just parroting a version of the Ellen MacArthur Foundation. Their definitions are very uncomfortable because they include things like regenerating nature, or include things like the environment. From a measurement standpoint, is not something we know how to measure. So if you ask them to put a unit of measure on the environment's restoration rate, it's very hard thing to quantify. So for NIST, we tried to look at a very sort of practical engineer or scientist sort of way of framing this so that our scientists would really understand how to focus their work. So for us, the circular economy is keeping atoms and molecules inside the economy, producing value and out of unwanted sinks, such as the environment. So it really is about the ultimate atom economy of our system. And the reason we have this little doodle on the left is because if you think about material coming in from the top, natural resources, we have the super sophisticated front end with extraordinary complexity and interdependencies of different materials classes, and a really incompletely built back half that does not recover the value of those atoms and molecules as well as it probably could.
Hey, Kate, can I stop right there for a second?
Absolutely.
But the, okay, so there's a political aspect to this atoms and molecules thing versus actually recycling things, right? In other words, once you say atoms and molecules, you've decided that you can take things and put it into in other words, you haven't said energy either, I see either. In other words, like if you take breaking plastics down to atoms and molecules, there's a huge energy cost to do that pyrolysis. This is what pyrolysis. Once you say atoms and molecules, you're talking about pyrolysis of plastic, right?
No, we're not. We're just talking about atoms and molecules. Maybe we're talking about the molecule staying intact through a mechanical process. It's about atom efficiency and retaining, the translation to energy is minimizing the amount of energy that you burn, because you could also look at the carbon cycle in terms of CO2 production in this. And one really important point that I always make on this slide is that, we are not immune to the thermodynamics. We appreciate that entropy is always present. There is no perfect system where you have 100% retention, but the argument is you could be doing much better than you are generally.
The question is how you're going to get the solution, right? In other words, if you frame the question like you're going to recycle materials as materials they are without loss of energy in the process.
No, it's never perfect, right? But it could be much better. And I think this includes aluminum, it includes concrete, steel, and one of the ways that you can retain, the idea is that once you pull an atom or a molecule out of a resource, whether that is a mine or a fossil feed, anything else, once you pull it into the human sphere, you want to keep it there, producing value for as long as humanly possible. And there's no value judgment on that other than asking quantitatively, how well do I support decision-making in that economy? All right, what are the tools I need to make good choices about being able to continue making money and employing people while also preserving these valuable, and in some cases extremely valuable, if you want to talk about critical minerals, resources inside the system.
But I mean, if you want to say like paper versus plastic, for instance, right? And then you're saying that the paper can be pulped again and made into paper, but the plastic, a lot of the plastic, like automotive plastics and electronics plastics, it can only be pyrolyzed into something that could possibly be used with low-grade fuels, maybe.
Yes, I would argue that a large amount of automotive plastic is actually made from mechanically recycled resin, which is pulling oftentimes a lot of single-use material into what we would call a durable good because of the lifetime of the vehicle. And I actually have a slide about chemical recycling that I think puts it in a little bit of context. So we're going to talk a little bit about mass balance, I think, and mass balance accounting is, it's complicated. It is not mass balance the way engineers think about mass balance, but it is the way people think about how to account for recycled content, like pyrolysis. You have to make very clear choices about the energetics of when to use pyrolysis or when to use any kind of process versus the mechanical one.
I'm really not trusting of the words that people use, especially the government, when they start saying words like atoms and molecules, and it has meanings that are very, in other words, people don't recognize that there's certain things buried in the terminology that say things, and that ends up being implemented in regulations that ends up being how we live our lives.
So atoms and molecules, I would argue, do not have a political definition. They have a strict scientific definition. And for NIST does not regulate anything. That's a really important point to make. It is our job to facilitate commerce. So we don't, it's not that we're going to go in and dictate some political definition of atoms and molecules. We're saying we're scientists and engineers. And what we know how to measure is process control, massive and energy efficiency. And you should look at this from a very strict quantitative measures standpoint and not some subjective definition that you can't measure.
Yeah, and this doesn't regulate, but there's a federal environment, right, that you're in. And it, like, for instance, committees that you're on, things, and that basically there's an opinion that comes out of all the agencies. And that's where the regulations come from, more or less, the way I understand it.
So that's a separate conversation. So most of the regulations are set by other agencies, and we spend a huge amount of our time trying to supply technical expertise to inform their choices. if you want to talk about the policy positioning, a big part of my job is just explaining to people how the system actually works, because there's a large number of people with interests in this system who do not appreciate how we actually make plastics and polymers and where they end up. So I spend a lot of my time explaining to people that their understanding is not reflective of the real economy or the real system. I should also say that I spent the first 15, 20 years of my time at NIST really supporting a lot of collaboration with industry, mostly big industry. So the major chemical and materials manufacturers, learning about their problems and trying to supply measurement solutions to help them make things more efficiently. So that's
really interesting. I mean, I think the regulation things are really, I think people need to understand how the sausage is.
Yeah, that's a separate class, I feel like. I mean, there's a big there's not many people, I think, who have a clean understanding of the way the sort of federated democratic republic works. It is a unicorn government system. It also makes it very difficult in international negotiations for us to find a way to craft agreements that we can join, because actually our federal system has severe restrictions on authorities that other countries don't either appreciate or take seriously. So we spend a lot of our time having conversations about authorities and where the authority actually lies, and frequently the authority does not lie in the federal government, and that is often what restricts us from being able to participate in things. No value judgment on that at all. It's just the way our system works.
Yeah, there's a lot of different forces, right? I mean, the business is one of them, and the thing about working with business kind of grew out of the Carter years and things, right? In other words, not Carter, Clinton years, where the government kind of decided to have credos and things to interact with business. And then this wasn't always business that close, right? In other words, I know the Department of Energy suddenly became very interested in business in those years. And then
so cooperative agreements existed well before that, really in the 70s and 80s, mostly in the 80s was when they became sort of diversified of the instruments that were used to form agreements with private sector entities. It was the Bush administration that created the Technology Innovation Program that I think tried to strengthen the relationship between NIST and the private sector. That was a program that the Clinton administration supported, and then the Bush administration and the Obama administration both mutually agreed to kill, right? So is that one party or the other? It's just the evolution of the system. NIST restructured in the late 70s, early 80s, and that was when it really broadened its mission away from just standards. They had Bureau standards up until the late 70s, and then in the early 80s, 82 is when they were rebranded and asked to broaden their portfolio into other areas.
Yeah, it just seems like there's a lot of, I just think there's a lot of it at play in I mean, this can invent the terminology of how we deal with circular economy and plastics, put it that way, more or less. And the people in the government who argue with what they say. So it matters a lot, like how it's phrased, right? In other words,
it would be awesome if more people embraced it, but I can tell you that they generally aren't, because they would actually prefer to use the Safety 2.0 definition provided by legislation than anything that NIST says.
It seems like a lot of what came out of the committee, the report that we looked at, is just supply chain decisions, like not buy water bottles and things like that. Give people like reusable water bottles, like nothing substantial seemed to come out of it, right? Like it seems like work a lot of people put into it, and then like water bottle purchases is the main thing. Like,
are you talking about the CEQ report?
July 2024 report. Yeah, I think.
Yeah, that's not legislation. That's an important distinction. That came from the White House, and it was written by the Council on Environmental Quality. And it is a reflection of those authorities that we either do or don't have. And they felt that the biggest influence the federal government could have was by its purchasing power, because it is one of the largest purchasers of goods in the United States. So they have thought at times that if they shifted how we can buy things, it would drive change in services and goods. That's why we're, and too much.
Yeah, when you look at what the EU's done, I mean, there's a whole several orders of magnitude difference, right? In terms of what's going on, in terms of regulation.
Yes, I spent a lot of my time explaining to people also the trade-offs, that you're really never looking at a net. The system is never perfect. And when you take one thing away, something else fills its place, right? You take away the plastic bag, you put a paper bag there. Was that better or worse? Depends on how, right? If you get rid of the plastic water bottle and you put a metal one in everyone's hand, but nobody can keep track of them for more than a few weeks, is that better? Probably worse, right? So I have like a coffee mug that I've had since like 2007 that I walk around with, and I'm like, any day now, it's going to be less environmentally impactful than if I had just been drinking out of water bottles for the last 17 years, right? Or whatever, 17. So it's a trade-off, everything. When East Palestine happened and the vinyl chloride spilled out of that tanker, we had colleagues in other agencies saying we should just ban PVC. Is that a good idea? It's probably an idea. You know, people like water. And we kind of agreed we weren't going to make the pipes out of lead anymore, and we don't really have enough copper. So you can ban it, but you have to know what's going to happen after you do that, right?
Well, it's replacing with plastic pipes now. I mean, Cincinnati's LyondellBasell's making a lot of the plastics going into replace pipes, so they're pretty happy about it.
Well, the other thing I said is you ban PVC. That is probably the best news that a company like ExxonMobil is going to get for a decade, because they're going to replace all the PVC with high density polyethylene, and it will dramatically increase the demand for their product. And you'd be surprised at how upset some people get when you explain.
Yeah.
This is my job.
This is now all coming from fracked natural gas, so it's affecting the water supply too. It's like everything's linked together, so.
That's right. And everything comes with trade-offs, because you're always gonna, you've had 6 billion, at the end of the day, you have 6 billion people, right? And the volume of material moving through the system is extraordinary. And a lot of the ideas we place material are not able to that scale.
Yeah, that's interesting.
So you need something that you can make, really at the end of the day. I work with colleagues, quantum information science, artificial intelligence. These are our fields important to some of my colleagues, and I have to explain to them, if you can't make ethanol in hundreds of millions of metric tons, you can't have quantum information science. You can't have any of this stuff. You can't make microchips. Like you don't understand that these platforms are called platform chemicals for a reason, and we have not supported the evolution of that industry at the level, should have been for the last 50, 100. And if that crumbles, trouble.
Yeah. Any comments from anybody, or? One chip in. All right, yeah, so.
So anyway.
Mass balance, whatever.
Yeah. So this definition helped our scientists formulate how they approached the problem and asked better questions. For us, it is not just plastics. So we have efforts around critical minerals, batteries, concrete, food. All of these things are interdependent, and we have people working on all of them. The program is divided into 3 categories. So there's basic material science, there's data and decision tools, and there's environmental impact. And we've done a lot of work to support various aspects of this, engaging with industry to understand what their real problems are. I talk a little bit about the policy piece, but I'm trying to skip through to the mass balance. We can always come back to this after we talk about mass balance, but the global diplomacy side of this problem is substantial. and the spin up of discussions and dialogues and agreements is extraordinary. So trying to be supportive of the discussion in ways that, using technical expertise to try to inform the conversation so that it's as thoughtful and constructive as possible is a huge challenge. All right. Let's talk about mass balance accounting. So mass balance accounting was not something on our radar until about 4 years ago when Congress asked us to do an investigation of how it was being used for chemical recycling of plastic waste. I hope you have discussed in your class the various pros and cons of mechanical versus chemical recycling. It is generally considered that mechanical recycling is, when available, the most energy efficient and highest recovery method to recycle plastics. This is a great diagram my colleague from the Association for Plastics Recyclers, Scott Trenner, uses. He describes it not as a circular economy, but as a spiraling whirlpool economy where things slowly devolve into value products. So when you mechanically recycle your plastics, if they're not well sorted, if you use aggressive conditions for your extrusion, whatever, you can see some degradation in properties. Things slowly find their way into value added applications. This comment is the smaller slope of decay, the better it is for the economy. But inevitably, you are going to find the lowest life form product, which he jokingly describes as the flower pot at Home Depot. The black super pot that cracks as soon as you pull your plant out of it. And that's the plastic you want to go into chemical recycling. Now, is that exactly chemical recycling? No, it is not. But the question is, are going to ultimately have to rely on it for some of your recycling processes. How do you trust the claims that are made about the recycled content of resin that comes out of chemical recycling? There are many used to recycle. Some of them you can crack your atoms in, you can't, right? If you're going to stick something in a pyrolysis cracker, you're not going to be able to count carbon atoms and say, these carbon atoms all came from my recycled resin that I put in, and these ones did. Most pyrolysis operations require very, very low recycled content carbon going into them. So they're putting a small fraction of material into a very large primary fossil vat, and they're spiking it essentially with recycled content. And in order to promote the increase of that resin, but to do it in a way that doesn't compete with mechanical recycling, we were asked to provide an analysis of how to think about mass balance accounting, but also how it might fit into the system in a useful way. Is that fairly clear?
Yeah, that's good. So but all right, what's not mentioned is that there's groups that want to have mass balance accounting, there's groups that think that don't.
Yes. Yeah.
So it's like, who gets to decide what the future is going to be, where it's going to go?
So yeah, turns out mass balance accounting is not a new thing. In fact, it has been used extensively to transition other markets to more quote unquote favorable. So it's actually, if you ever buy something that says fair trade coffee or sustainably produced palm oil or organic, these are all attributes that have been defined using a mass balance accounting method or something that's called a chain of custody model for those claims. If you have to pay, chosen to pay the extra money on your electric bill to make claims about electricity coming from renewable sources, turns out a lot of that is using a chain of custody model where they bought credits from a solar farm in Arizona or a wind farm in Iowa and moved the electricity credits around so that you could claim, that those were the electrons you were using. Those were not the electrons you were using. They still came from whatever plant was supplying your electricity. But there is this very healthy market of trade in accounting for alternative energy sources.
But Duke Energy has a trading floor in Cincinnati that trades alternative energy credits. It's like a stock market.
Yes. And my next slide, we can talk a little bit about how amazing it is that that works and how it will never work for the chemical industry. So we wrote this report. We ran a workshop that was a combination of industry representatives and this whole other cottage industry you may or may not know about called certifiers. So there's this whole industry of third-party certifiers that go in and analyze the books, basically the ledgers of companies to verify that they're using whatever method that particular certifier uses to support claims. When verifying that you're going to make a claim about this new product that's come off your line. So in paper, if you want sustainably sourced paper, there's 4 major global certifiers for your sustainable content in your paper. It is extremely expensive if you're a small or medium business to retain all 4 of those qualifications for certification. So it's a real barrier to trade if you're trying to be able to sell your product to as many people as possible, if you have to maintain all of those different certifications. So we made some recommendations. We tried to write a report that said, look, it's not perfect, and you have some choices, policymakers, about whether you want to support this industry or not. And if you want to support it, you can make these kind of choices. And if you don't, you can make these kind of choices. But, you know, I'm not here to tell you what your value judgment should be, but I can tell you technically what the impacts of different choices are going to be on the system. So we wrote this report. At the same time, the International Standards Organization called ISO, that coordinates global standards, started a new item of work in their chain of custody committee. So this is another part of our life that we deal with all the time, which is the documentary standards process, which is critically important how practices translate into commerce and how a business works from business or transactions. How do you make claims about all of the attributes of your material or your chemical? So through that work, I've been trying to help support good documentary standards, but that documentary standard has to work for everybody. It has to work for energy, ag, chemicals. Like there's 5 or 6 different industries all in the room together trying to figure out how to write a document that allows everybody to try to elevate their practices in a way that's credible, traceable, verifiable, you know, supports transactions and trade through the supply chain. And chain of custody is an umbrella of terms. It includes everything from on the bottom left, you'll see book and claim. You know, if you have yellow A, which you can think of as your solar energy or your recycled plastic or your organic apples, if that's the yellow bucket and the blue bucket is your like old-fashioned either primary fossil feedstock or you know, coal generated or natural gas generated power, book and claim means you're just going to throw some stuff into the mix and whatever comes out, but you'll make claims that have nothing to do within the actual barrel that you sold to somebody or the bucket or the electrons. It's based entirely on this marketplace that you create to trade credits. It's been working in the power sector for a long time, since at least the 90s, right? Nobody bats an eye, nobody asks any questions. The power industry is largely, you know, monopolized through public-private kind of systems, and it enjoys a certain amount of trust that we're doing things in a credible way. Are we? I have no idea. Just saying, nobody's asked any questions. The next level up is mass balance. And mass balance says you can do a couple different things, but
well, I mean, if you wanted to cheat at that system, how could you cheat? Have you looked at that? Like, how would you cheat at it?
yeah, in book and claim, it's a transactional thing. So there's plenty of ways to cheat it. My joke that I like to make is, you know, the important thing is that my sheet of recycled paper, like you can't count 6 trees in 2 different countries as being, you know, just in this piece of paper. You know, it's it requires a rigorous system of verification and validation and ledger-based tracking. And there's plenty of ways to cheat it if you want to cheat it, right?
Like they claim that they sell part of the Amazon, but it illegally gets turned into grazing. They chop down all the trees and graze cattle on it. Then
Or they
notices that
Right.
happens.
generate an electron from a solar panel in Arizona, but it gets sold 6 or 10 times over in Ohio, Pennsylvania, Maryland, and Montana, right?
Right.
At the other end of the spectrum in the top right-hand corner is the identity preserved. It means all of my organic apples came from this orchard, and my bushel has only organic apples from this orchard. And I can make perfect claims, and there's a chain that I can track that tells you that it's absolutely perfect, right? This is when you make a mechanically recycled part that is 100% mechanically recycled. I know that doesn't happen, but right, it is this perfectly idealized system.
Well,
And
it can be water with a PET, right? I mean, PET can be kind of close to that.
So you can get very high yields back from chemical processes. Sometimes, generally, when it's mechanically recycled, it often has to be spiked with some amount of primary material. Right. In between these extremes, you have different layers of accountability or traceability and mass balance. If you're going to put 0.001% by mass plastic into a pyrolysis process, you know, am I really going to care as a consumer if I'm pick up a shampoo bottle and it says, oh, 0.001% recycled content? No.
Yeah.
They would like to be all the carbon from the recycled plastic ended up in my resin. So it's really 30% recycled content there. And all of the molecules, all the benzene, all the other stuff that I pulled off of here and sold, that's all from my fossil carbon, my primary carbon. Like they want to be able to shift where they can margin on that claim into that product. And by allowing people to do that in a controlled way, you incentivize the increase of the use of that attribute in your system. So if I know that my barrel C, I can make stronger claims on and I get a much higher price for that good, it encourages me to make more and pull more recycled content in if I'm using trusted, verified.
Yeah, I just see a lot, the petrochemical companies seem to be really interested in pyrolysis, and they like new pyrolysis, they call it different things, right? And then, but basically, that makes me think they must be trying to get away with something here, you know, but it doesn't seem like legitimate.
The other thing they want to do is that a large amount of the input is actually burned for energy. So the heat that's used to heat the reactor is coming from the burning of some of this content. And the question is, how do you account for that? You know, you have a lot of choices in how you do this, and there are policy choices. They're not necessarily technical engineering based choices. You have to, that's where science and policy really touch one another. You know, you have to understand the implications of the policy you're creating and do it intentionally with purpose, or you're going to tweak an exceptionally complex, very important system in ways that you can't predict the outcome of. And the odds are the outcome's not going to be great for a lot of people. But chemical industry needs mass balance to work, and they need a system that they can implement. They don't have trust as a sector. Exactly what you said, Professor Beaucage. They do, you know, if they want this to work, we're immediately suspicious of why. And that's where all of this other work comes into play. Why the documentary standards, why all these certifiers want to work with industry, a claim that they can use to put on their material that will give it and allow them to. You would much rather. Palm oil actually worked beautifully for palm oil. We've gotten much closer to a higher content of responsibly sourced palm oil because they used mass balance. And now a fraction of the palm oil market is working in these kind of controlled blend and segregated marketplaces where they can actually make enough responsibly sourced palm oil but they can use a higher integrity business model for how to trade it. Right? It is a transition to get to something more reliable. And that was why we report the way we did. We were like, you need to use a progressive policy that maybe is more progressive or more permissive, excuse me, at the beginning, and then slowly tightens its grip for higher and higher performance metrics so that you drive an industry to grow in a way that actually maximizes the responsible use of this resource. This is not the way the conversation plays out in articles like the ProPublica article or in many other discourses where it has to be all either good or bad, right? It's either meant to corrupt or meant to deceive, or it's you read all these different sort of opinion pieces because it's extremely complex. If you don't have a degree in chemistry or chemical engineering, if you haven't spent time in these places, you don't have trust in the industry, it's really hard to explain to someone how this works, what it's meant to do, whether or not there's a way to keep people honest, right? And that tweaks people to behave in ways that just, aren't super helpful.
Yeah, but I guess part of it is because of people, some of the people like ProPublica are kind of excluded from the decision tree. I think they don't feel like they're vested in the system. So that's a problem. Like somehow they have to be brought in.
I think there's also a shift in society at large that most people feel that they should be able to understand everything about the modern world, and it shouldn't really require education. That information should be accessible to anyone and understandable by anyone. I think that there's a decrease in the value of a very deep and rigorous. Are all our advanced degrees deep and rigorous? We can argue about that. I'm not, but I will say that most engineering disciplines contain really important skills. The lead negotiator with the State Department has a bachelor's degree in chemical engineering, and I told her once on the train how grateful I was that we had somebody like her with her background doing this job. And she said, "Oh, you don't understand. I hated getting my undergraduate degree in chemical engineering. I always wanted to do policy." And I said, "I don't care." I said, "You took thermodynamics and you can't give it back." And the number of people in this room who do not appreciate entropy is substantial. We need more people that appreciate, right, those
that's true.
irresistible forces working against us, make the system better. It's really hard to explain to people that don't have that background.
Yeah,
Sorry.
I agree. The expertise isn't trusted, that's for sure. That's a problem.
No. Important. And the problem is there's plenty of people trying to defraud them all the time, and that's not helpful either.
Yeah.
So I said I would say something about this.
Yeah.
I know you've shared with your students that there is a negotiation going right now to address plastic pollution in the United Nations Environment Program. I've been invited to speak at the World Trade Organization in Geneva. I've spoken to the Asia Pacific Economic Cooperation groups, and I serve the U.S. negotiating team for this treaty. I see it says agreement by 2024. They took that to its greatest extreme, and the goal is to have it by January 1st of 2025. The last negotiating conference is over Thanksgiving week in Korea, and they're hoping to arrive at some agreement that most nations can sign on to. But it has been extremely difficult.
It seems like it's similar to the COP meetings. Is that true, or?
So COP stands for Committee of Parties, and those are the meetings they have after they've established agreements. And so there's a whole host of environmental agreements. There's Minamata, there's the Paris Agreement, there's, we dealt with ozone and mercury, all these different things. And all of those treaties or agreements have a series of COP meetings that proceed after them. So there's a COP6, COP23, the people that work on the events travel constantly to attend these conferences of parties to discuss progress on the agreements that they've made.
But then, anyway, the critique of the COP meetings is that the COP environment meeting, the global warming meeting, whatever it's called, the climate change, I guess. That people say that it's run by the oil, the meeting is held in the oil countries, right? And then it basically, mostly the people that are there are oil company executives. And there's not many of the people that are like being affected. Is that true of the plastics meetings too, or is it the UN?
So the COP move, they aren't always in place. And so there was a lot of controversy over the recent climate change COPs being held in Middle Eastern countries whose economies are largely dependent on fossil. That was the controversy in that particular meeting, but it's not been the controversy at all of them. This meeting has moved everywhere. This is the 5th one. It's been in Brazil. It's been in Thailand. We've had meetings in Thailand, Nairobi, Paris, Canada. And depending on where it is, there is a private sector presence. It is only the member states that are allowed to be part of the formal negotiation. But there is this view of people that migrate around the facilities and are looking to essentially lobby, and that includes nonprofit organizations that represent fence line communities, populations adverse by plastic pollution, and more of one than the other, kind of depends on where it is. I think this one is especially controversial because it's supposed to be the last one, and I think they're going to have to make huge concessions that they have not been willing to make. And my next slide talks about really how we kind of found ourselves in a really tough situation, because the treaty says plastic pollution, right? What is plastic pollution to most of us? To most of us, plastic pollution is the stuff that we see in the environment. It's the bags, the fishing nets, the nurdles, the water bottles. It's that mismanaged solid waste of plastic material that has leaked into the environment and needs to be managed. I originally thought that was where we were starting, but silly me. There is a second layer to this now that is considered, which is the toxicology of the formulation of plastic products. So this includes dynamics of degradation as well. So it's the microplastics, the nanoplastics, the additives that are present, and the environmental dynamics of chemical exchange that may or may not be happening in the environment, which nobody actually, I would argue, understands or accurately, but is still a concern from these member states. So some of them want to take action on this, even though there's not really very good science underpinning what kind of action would have the outcome that you want, right? Like I said, trade-offs. We have a habit of making decisions about banning things without really thinking completely through exactly what we're going to replace it with. BPA being a great example. We banned BPA and we replaced it. I like to joke, we replaced it with BPB and BPC, which are molecules that look essentially the same, but are just chemically different enough to avoid the ban, right? Is that better or worse? It's a game of regulatory whack-a-mole that people are like, I'm only going to strike at the thing I can see that's bad, and I'm not going to ask the question about the other two heads that are going to pop up when I hit this one down.
Well, that's partly due to the people that made the substitutes, right? They're being disingenuous when they go and develop chemicals that are made potentially.
Yeah, regulatory systems too. The way we approach regulatory enforcement and decision making is not the best, and people, the system really encourages this sort of unresolvable exchange and really, really slow process of approval and
That's going to litigation. I think it's like they get frustrated and they have that outlet. So
Right, so there's the same litigation that will happen if you try to make a ruling about vinyl chloride, which is something that they're thinking about doing now, right? They've announced publicly that vinyl chloride is in review for consideration as a managed chemical. The third layer of pollution, which is also being considered, is the whole kit and caboodle of the whole life cycle of production. So it is the climate impacts of the refinement process, polymerization process, the manufacture of goods. It's the whole life cycle, and considered in a vacuum, it's become a kind of all or nothing discussion. We should ban the production of plastics and that is a level of that you have sometimes in these communities because people haven't sort of learned to appreciate how complicated that is and whether or not the world is going to be better in terms of its energy impacts or its environmental impact with or without these materials. But it's made the negotiation extremely confusing, complicated, very polarizing. And if they want by 2025, they're going to have to make some hard choices about what's included in this system, in this agreement, and what's not.
Let's see, I'm trying to read the bottom chart. So you have chemicals that are involved in the making of plastics, I guess, and then what?
Yeah. So these are pulled from a paper that we wrote in collaboration with Argonne, where we tried to, so life cycle assessment, I don't know if this is something you've taught in the class, but life cycle assessment are used to calculate environmental impacts of different processes, right? And so we did a intercomparison of the 5 major LCA tools used to characterize plastics manufacture. And we tried to define what was like the zebrafish or the fruit fly of manufacturing, which was PET, what's called cradle to gate. So everything from extraction to when it leaves as a nurdle or a pellet to go be processed. If we just compare that in the 5 known models, 5 data sets available globally, how do they compare with one another? Are they reproducible? Do you get the same results? Are we having, and why? Why are they different when they're different? So this is criteria pollutants produced. I believe this is PET, but I have to go back and look. And it's the 5 major models. So each, the blue, red, green, purple, and turquoise are each a different LCA model. And it's the criteria pollutants are volatile organic compounds, carbon monoxide, nitrogen oxides, particulate matter at the 10 micron scale and the 2.5 micron scale, and sulfur dioxide.
I mean, mostly, some agree, but mostly this is a big difference.
You can sometimes explain why they agree if you look at how the data was collected, and sometimes you can't. And sometimes it's that there's something baked into the way the model software was written that you can't see that's changing. And it's a really important separate conversation that NIST is supporting is how are we going to get these models to agree so that nation states and regions aren't talking past one another, because Europe wants to use eco-invent and the United States wants to use GREET, and our models give different answers, but they give different answers for sometimes the energy mix and sometimes because the models are different. And if the models are different, you're just having a kind of useless conversation about what's better or worse, or, you know, who's right or wrong. And we were trying to write a paper that said, look, this is not, I like to joke, LCA is kind of like Inigo Montoya and the Princess Bride. You keep on using that word. I don't think it means what you think it means, right? People want it to mean something that the system, the tools are not sophisticated enough to actually do well. And until those models can do it well, they can be reproducible, they can be transactional so that every company that does them gets the same answer. They research only thing. They are not something that informs your economic decision making.
That's pretty interesting. So the whole scientific ground you're standing on is pretty flimsy. I mean, it's till we start regulating, for instance.
Just providing better data and models, right? So that's This is where NIST can be super helpful in ways that regulators can't, because a lot of the standards work that we do is in the voluntary space. It's bringing companies together to agree on what they're going to call something. They agree to adhere to something that they've mutually decided, and it supports commerce and can elevate the quality of commerce in much faster, more productive, higher impact ways than just trying to tighten your grip on the system in ways that are often not really well understood. Sometimes it's very important that you do that, but when you have to, and when you can do it in a way that is much more sort of system driven, the outcome can be much, much better.
Yeah, that's pretty interesting. I mean, it definitely has a big advantage. I mean, the companies are worried about litigation too, I think, and that if they have a regulatory, if they can come up with a consensus over what can be done, then they're protected from that, right? In other words, if the government says you have to reach this level of emissions, they're much safer in that space than they would be if they were going to get sued without any definition of what's good and bad.
Yeah.
So there's a vested, they have an interest in it. It's probably the right way to go too.
We have a working group of LCA experts across the government, mostly in the Department of Energy's national labs, but also including, well, it includes NIST, it includes the US Department of Agriculture, it includes the Food and Drug Administration, it includes the US Geological Society actually has a very strong economic assessment team. But they are all coming together as their own working group to try to understand what to ask for in different sectors, what kinds of basically ground rules to place on the models so that they can really support industry in ways that make the most sense. And so that we're not expending more energy than we need to trying to control a system that actually could self-regulate if it's properly supported.
Yeah, that's pretty interesting. That's something I didn't really think of. It's pretty interesting.
Yeah, a lot of fun.
Yeah, it depends how you define fun, I think.
Yeah, there's days when I just want to go back in the lab and do some GPC, but
It's important, you know, I think it's important. Fun is another thing.
yeah, it's really interesting. And it's taught me to really appreciate the role of research and the role of our measurement. We have a whole lab behind me that I can talk about that tries to elevate nanoplastic and microplastic metrology to make that reproducible, to create best practices, to provide reference materials that actually allow you to calibrate against something. We're working with Hawaii to try to figure out what to do with all of the huge excess of fishing nets that show up on the shore of Hawaii on the Pacific gyre burps. It does with some strange, unpredictable pattern. They're trying to put nets into pavement, or they can into their asphalt, or put it in a concrete. All kinds of really interesting things. We have the circular economy program for us is spread across a huge range of and spectroscopy, analytical polymer science, yeah, economics.
Interesting. I think we're almost out of time, I guess. I think I promised them we'd be done at 4:30. So, but anyway.
We've really monopolized the conversation. I hope your students haven't been too bored.
Yeah. So, yeah, I think maybe any of you guys have any questions or comments or anything? Anyone have a better job at this? Or this is the first one, it's your time to ask.
Or how much do you think the UN effort is going to help with pollution?
I think that it has called out a hard conversation about the real source of pollution. So it's really different in different parts of the world. And it is hard to have a common agreement when many countries don't actually even have a solid waste management infrastructure. There's no collection of waste. Problems in those countries are very different than the problems in a country like the United States or in Europe. what I think it's done, call out a set of criteria that are, the way we describe it is it's kind of a menu approach. If you're this kind of country, focus on these things. If you're this kind of a country, focus on these things. And oh, by the way, maybe the developed countries should try to find a way to support innovation in solid waste management in countries that don't have it. I think that it will help. How much is not clear, and I honestly, I'm almost, I just don't know where they're going to end up in terms of what they're willing to let agreement, and whether or not nations can join. Right? You can write a powerful, very, very strict agreement, but the 5 countries that need to join it aren't going to sign it. So I think it has the potential to help. I am not sure this is the primary place to deal with the whole comprehensive problem.
Oh, yeah.
I'm sorry,
You
couldn't hear that.
wanted to know if it's gonna be, the video is gonna be posted online, but sometimes it doesn't record it, you know. So, but 50-50. But everyone else is okay, or? Yeah, okay, so I think that's what we got. One question from the students. But you know, the problem is they get used to watching video, Zoom things, and it's different than when people are here. I'm kind of used to Zoom meetings and stuff.
Yeah, I'm sorry, I'll be there in person. That's usually the most effective way to do it.
Anyway, maybe have you out sometime if you figure out, you know, we have the department seminar or something. You could have.
Yeah, that'd be great.
I know that there were like 2 faculty here, and a couple others asked if you were coming by. I think we can, because, you know, for the departmental seminar, we could have some time. I don't know.
Yeah. I'm a
Anyway.
huge fan of Granger's ice cream. I'm always happy to go to Cincinnati.
Oh, yeah, all right, yeah, that's pretty good. So you've been here. All right, so yeah, thanks for doing it. I really appreciate it. I think they got a lot out of it.
Thank you. Yeah, and you know, you're welcome to reach out to me. Any of your students, if you have questions, you're welcome to reach out. I am very, very easy to find because of my last name. So.
I was gonna, yeah. Yeah, I mentioned you can join us.
Yes. Yes.
Okay, thanks for the sign up.
Absolutely. Take care.
Thanks.